Okay, so this is the business forecasting overview. And what we're going to do is I'm just going to kind of introduce the idea of forecasting, give a few examples, and then go kind of at a high level through the techniques that we're going to be covering in class with a few visualizations. Kind of keeping the math a little bit light. We're not going to focus on that in this class, and just show how these different forecasting techniques will work in practice. Okay, so think of the following problems. I want you to predict the population of the USA, predict the sales of an ice cream in any given day, predict the price of a stock, and predicting a recession. The first should be relatively easy because the population of the USA goes up by a relatively regular amount each year. We also kind of have covariates such as things like immigration figures that we could use to kind of further improve our estimates. So predicting something like the population of the USA, even like 2, 3, 4, 5 years ahead, is probably a relatively easy prediction. Predicting the sales of ice cream might be a little bit harder, but maybe if we have in the near term, if we know things like temperature, we can still do relatively accurate forecasts. If we know some sort of relationship between ice cream sales and temperature. Now, a little bit more difficult is predicting the price of a stock. How much is the stock going to go up or down the next day? Somebody from a pure finance background will actually tell you that that's impossible because the price of a stock is a random walk. Other people might disagree with that, but we'll kind of leave that discussion to the finance class. But the forecasting the price of a stock, whether you know how feasible it is, it's still going to be a very difficult problem. And predicting when a recession is going to occur. So if I'm an economist, I can think about things like inflation rates, potential leading indicators such as consumer sentiment, but nobody really predicted the rapid recession in 2008. Nobody really predicted the coronavirus recession because that was, um, an epidemiological thing from completely outside of economics. So that's going to be again, very, very difficult to predict. So the idea of what we're doing with prediction is we're actually we can't be perfect, and certain things we can predict. If I'm Walmart, I can probably predict daily sales, but it's very hard to predict things like the price of the stock and when is the next recession going to be. There's thousands of PhDs trying to work that out, and quite often they're not particularly accurate. So here's like a few I thought were just kind of interesting links about commercial forecasting. So I put a few of these up before. If I can just press escape. So forecasting. This was a nice discussion on economic forecasting. Now, artificial intelligence methods are increasingly used in forecasting. Though there has been research that's shown that the simple forecasting methods that we're going to talk about in this chapter are actually pretty much as good, quite often almost as good as these very, very complex methods. So the tools that you will learn in this chapter actually are pretty good, and they're pretty simple. But even, the title of this article is even with AI, economic forecasting is going to be pretty risky. And again, here's from somebody who works in finance. And, the finance industry actually, employs a lot of people with PhDs in math and statistics to build complex models. So, again, artificial intelligence is being used more in forecasting, and a lot of things can be forecast in finance. Things like option prices, things like, general stock market prices, runs on sectors, things like that. So there's a wide variety of scope for forecasting in finance. Not always accurate, particularly when it comes to things to do with the stock market, but it's a very important kind of field for forecasting. And sports forecasting, who's going to win? Every time you have a sports game with the increase of online betting, you have a set of odds, and these odds are based on forecasts from previous games. And there's a manual way of doing it, but there's also forecasting systems, AI forecasting systems, and again, the idea is you can never be perfect. Given any NFL game, you can probably say a certain team has a 70% chance of winning. But because the NFL aims for parity, it's very unlikely that you're ever going to get like a 99% or 1% chance of winning. So again, more advanced AI systems are being utilized to improve and kind of incrementally improve sports forecasts. The last little link I actually want to show you, I'll show it you now, and I think I link it somewhere in the slides, but you can actually just do a search for it, there's a very good free forecasting book out there which kind of expands some of the simple things that we're doing. We've only have a week to do forecasting, but if you're kind of interested in this topic, this is the standard textbook and it's free, though be aware that most of the actual implementations are actually in the language R, they're not in Excel. But this kind of takes forecasting from a very simple kind of a very simple level to kind of quite more complicated mathematical forecasting techniques. Some of those which we'll actually cover this week. Okay, so going back to our types of forecasting. Our first type of forecasting is judgment forecasting. Just give me a second. Okay, so judgment forecasting is where we use expert information. So if I'm you know, I'm a retail manager, I work for Walmart. I pretty much know how much we're going to sell any given day. I could probably make a reasonably good expert judgment. So if I have field information about a field, I have certain, almost inbuilt knowledge that will help me judge something in that field, and that information can be utilized. We have a warning here from the text I just showed you, and that is judgment can be clouded by personal or political agendas. So, for example, if I'm a Salesforce manager, I might want to keep my forecast low so then I can say that I beat my forecasts. If I'm a politician coming up to an election, I want to maybe keep my forecasts of unemployment, inflation relatively low. And there's often issues. Most countries have a statistical agency that produces economic forecasts, and in certain countries, there's actually been issues of people working for these agencies being pressured by the government or imprisoned in order to force them to put the statistics that the government wants out. Another thing is, for example, we have anchoring towards a reference point. By anchoring, we have some previous values, and we're kind of very focused towards those values. It prevents us from looking at the bigger picture. So, for example, again, in the post-coronavirus environment, I'm trying to predict. I have some previous data, and I'm going to trying to predict for online sales for a new product. But since that data and the pandemic, the way people have consumed has really shifted, and there's more focus on online ordering and kind of curbside ordering. So my anchors might be a little bit out of date. And some of these kind of almost psychological heuristics, such as anchoring effects. There's a nice book by Daniel Kahneman, who won the Nobel Prize for kind of psychological biases and psychological forecasting, that kind of explains some of these things in layman's terminology. So again, maybe not during the semester, but if you have time at the end of the semester and fancy a nice light read, that might be something that you want to look at. Okay, so forecasting using analogy. Maybe we have some information that we think is a good maybe leading indicator for something else. So here we have one of the probably the biggest US kind of estimates of consumer sentiment, which is done by the University of Michigan, and it's basically a score of kind of consumer sentiment. And you see, the higher the sentiment, the more consumers are actually positive about how the economy is going to perform. So you can see here there was a huge dip in consumer sentiment to the recession of 2008. Then there was a gradual rise, and we had the coronavirus pandemic, just went off a cliff, then started to rise again, and now there's the current worries about um, inflation. So this is maybe seen as a leading indicator for economic forecasting. So we may want to put this into some sort of model of future kind of consumer sales or future GDP. So again, we're not going to build lots of kind of multi-series models in this class, but quite often we just think of some metric which we may use to utilize another metric. Another example, I utilize in a marketing class is like we call it the McDonald's analogy method. I think it was pioneered by McDonald's a long time ago. Is we're looking for market potential, forecasting how many McDonald's we could put in the new retailers we could put into a new country. So say we have Buffalo Wild Wings in the US, how many Buffalo Wild Wings would we put in the UK if we moved to the UK? Well, we basically kind of work out the number of people per Buffalo Wild Wings in the US, and then we kind of divide that into the population of the new country. But then we can alter it by various things, such as the ratio of the GDP, the ratio of how much chicken people eat, and we use this as kind of an analogous method to get some really rough estimate of kind of market potential for our retailer in the new country. Um, and this was mentioned, and this is just one of many methods for kind of coordinating group judgment. It's probably the most famous of these. I know it's used quite a lot in the supply chain industry, and Rand who actually developed it, actually have kind of quite a nice little. Let's just go back, remove the AI systems. Have quite a nice little page where they kind of overview the method and give some current cases, and also some academic papers on the Delphi method if you're really interested in it. But anyway, the Delphi method's relatively simple. We have a lot of experts in the area, so maybe we have a lot of um, experts on coffee prices, and we're trying to guess the price of the coffee next year in order to decide what options we want to buy. And what we will do is we'll have a questionnaire, and we'll ask them, do you think the price of coffee is going to fall or rise? And then maybe more detailed information like, what factors are going to influence coffee, justify your forecasts, etc. Then we have kind of, so we create a questionnaire, we have people answer the questionnaire. Then we have a facilitator, again, as an expert, and they anonymize it, combine the forecasts, and then give explanations for the forecasts. And then the idea is we keep on repeating until we get some sort of convergence in the people in the groups. And this can be used for forecasting. It can also be used for kind of decision making, idea generation, design, and lots of different things. It's quite a general idea elicitation method. So we've kind of got we've discussed some basic forecasting methods. Let's look at some quantitative data. I've given you a few data series, and these are ones I created these in R, but you could create these with a line plot in Excel. So this is the Amazon revenue, and you see that Amazon has been this very successful company. A few things you note: it's very seasonal. We've got always have a peak in the fourth quarter, then it dips, and then it kind of starts rising again. So we have this kind of we have a trend, and in fact a trend that's increasing all the time. And we also have um, some degree of seasonality or periodicity, in that we have different results for the 4 different quarters of the year. And we'd often get that in other, we'd often, if we had monthly data, we'd probably see something similar for retailers. Here's something that is kind of periodic, but is actually irregular periodic. So I got this from Google Trends, and this is this well-known pop artiste called Taylor Swift. And you see here that we have, for Taylor Swift, we have these peaks of popularity. Now, this is probably when she releases a new album or has some news story about her. So there are periods here, but they're not quite as regular. So we couldn't model kind of seasonality with this. So this is actually quite hard to model without external information, such as, knowing when albums are released and things like this. We actually have the US housing market, and I think this one's been detrended in that it's had seasonality removed. So this is a non-seasonal kind of graph of US housing. I think I got this from the Fred. Just for interest, let's go back. If you're ever interested in economic forecasting and economic series, or you're interested in that for a project, fred.stlouisfed.org has just a huge number of different data series available, from anything from different kind of financial indicators, different consumption indicators, US indicators, global indicators. So we go back, and then we have the US housing market, and this is a little bit out of date, but we can see this big dip kind of in the last recession. 2008, house prices were doing well, and slowly a recession unwinding over 2 years in the financial crisis, and then increasing again. And I thought this was kind of quite nice. This was when I produced most of these. If anyone's interested, I could give you the code if you program in this. But I found I took the revenue for Amazon, and I also took the actual earnings, which have some periodicity, but not quite as much as the revenue. And the earnings is actually much harder to predict, because we can be increasing revenue, but we could have sort of big expansion costs at a certain period. For example, Amazon is buying huge amounts of aeroplanes for its new logistics fleet. So it's quite hard to actually predict earnings relative to revenue. Okay, so these are the methods of forecasting, which I think I put in previously. So let's just kind of talk about some simple methods of forecasting, and then we'll go through these. So the first one, I just wanted to kind of summarize a few of the ones that are kind of discussed in the paper. So the first is to utilize the mean value. And why do we want to utilize the mean value? Well, reversion to the mean is the iron rule of financial markets. Now, it's not that simple. I'm very doubtful, with trends of increasing population, increasing in material costs, labor costs. I very much doubt that if we took like houses over the last 20 years, I very much doubt that house prices are going to return to the mean. But this is just a very simple forecasting method. Naive forecasting, we'll just take the last value. Quite often, if you have, for example, things like the previous revenue, then it's quite hard to model. Apart from maybe here, naive forecasting might actually give you decent answers. Seasonally naive, Amazon, you can't really forecast the next fall period by taking the last summer period. So, say for example, for a retailer, we want to predict December sales, so we take the last December sale. Seasonally naive. And then a little bit less naive, so we can incorporate both a little bit of this series is moving, is the moving average. And then we decide the period of the moving average, how many periods, and we take the average for the last periods. Now, this allows, if we have a series that jumps up and down, it allows us some measure of reversion to the mean, but at the same time, not over the top in that, we're not going back to taking information from 10 or 20 years ago. And generally, we can we can find the best K by tuning over the training data, and then seeing, doing one ahead forecasts, and then seeing how well each K performs. So here's our prediction for the housing, which I thought was kind of interesting. Now, because of this upward trend here, none of these methods really perform particularly well. So as of 2016, what's my house price is going to be? Well, naive is just, okay, we take the last value. Seasonal naive, we take the last value for the season. And the actual mean, we just take the last value for the period of the data set, the last 10 years. And we can see in all probability, we saw the previous value. My actual values were up here somewhere else. So that was possibly not the best prediction. We get the same for Amazon. We get the mean down here, which is not very good at all. We get the naive forecasting here, which is much better, but Amazon's shooting off this way. And then we get the seasonal naive. And then I thought I'd calculate the moving average for Taylor Swift. Again, we have the mean, the naive, and then the seasonal naive. And it's not, Taylor Swift is not really seasonal. This is only going to work if, she releases an album every December. Say, I release my album December on the dot every year, which doesn't really happen. But this is the moving average for Taylor Swift, which kind of it works better, but you can see the moving averages tend to lag the actual data. So this is a big spike. We only incorporate that spike in later periods. So we can kind of be kept a little bit unaware, but you see these forecasts. And what this graph is doing here is like it's doing one ahead forecasting. So based on the information up to time period t, we predict t equals 1, and then we look at what was actually done for t equals 1 and see the difference. So this is the moving average. Okay, so the first of the methods that we cover in class, we're going to do these in kind of Excel sheets. So this is exponential smoothing. And again, basically, we have a level which we use as our prediction. And all it is it's just a weighted sum of the previous forecast. The y hat is the previous forecast. And basically, t equals -1. So it's basically our forecast here is basically a weighted sum of our forecast at t equals -1 plus the actual value. So if here, for example, we forecast revenue of $1 million, and in fact, it was $2 million, then our next forecast would be $1.5 million. Assuming that we had our alpha as 0.5, if we had our alpha as 0.5. And again, what we do in Excel is we test how well this performs in terms of error at each period, and then we can use Excel Solver to find the best value of alpha to fit our data and hope that that works going forward. But again, this is very much based in the past. If our data is like rising quickly, we don't have any concept of trend, so we can't really forecast that trend, so if we have something that's relatively stationary and we don't think it's changing, it's just kind of moving around a certain point, then exponential smoothing is useful. So here's our example of exponential smoothing of Taylor Swift. You see here we have our prediction, and the prediction doesn't change. It has no trend over 5 periods. And we also have confidence intervals for our predictions. Now, again, this I did in R. When we do it in Excel, we can't really create those. We're a bit more naive. We can't really create those confidence intervals. But this is just showing our forecast for Taylor Swift. Now, Holt's method, and again, I've got these equations. These are actually from, I think it lays it out quite nicely from the free forecasting textbook. But I'm not going to give the exam. I just want you to understand how we utilize these methods. I'm not going to give you questions on these equations. So the idea is we have the forecast is we have a prediction of the level, exactly the same as exponential smoothing. And we also have a prediction of something called a trend. So if H is the number of periods we're forecasting, we also predict, say for example, we have sales of $1 million and we think they're increasing at $100,000 a period. Our forecast for period 1 is 1,100,000, period 2, 1,200,000, 1,300,000, etc., etc., etc. And again, we update all of this from our forecasts. So our level is very much the same as before. it's basically a combination of our actual, the YT is our actual value. This is the LT minus 1 plus the BT minus 1, the previous level plus trend is our actual forecast of the value. So for period 1 in the example I gave it was 1,100,000. And then we also update the trend based on, the actual difference between the levels and what we forecasted given our previous trend. And this time we have an extra parameter beta, which again is we're updating the trends based on a weighted combination of our previous forecast and the actual change given the last data. So the idea is, again, this involves a little bit of reversion to the mean, but kind of not so much. It depends on your parameters, how aggressive you are. And again, we kind of fit these alphas and betas in Excel by, forecasting each period and estimating the error and predicting, getting the alphas and betas that give us the lowest error. And so here's our prediction of the housing for Holt's method. It actually looks a little bit like the value. So we see here we've got this trend here, and Holt's method continues the trend. Now, a lot of business forecasting, if we have a quick trend, it's unlikely to kind of continue long term. So, for example, if we have Amazon has exponential revenue growth, it's going to tail off equivalently. So there's actually a damped Holt's method, which we really don't talk about in this chapter very much, and that will actually has a little bit of damping on the trend. You assume the trend gets less over time as we do forecast predictions. And then our third value, again, we have, amazingly, we have a third kind of update parameter. And this time we have the level, we have the trend, and we have the seasonality. The level and trend are as before, but the seasonality basically says, we've got this constant level and trend. How much extra would I need for the winter period if I'm a retailer? How much less would I need for the summer period? And like the other values, I'm not going to write this all out algebraically. The idea is we look at our previous estimate of seasonality and the new estimate of seasonality, and the new seasonality based on our past data. And again, we do a weighted update of the average, and we fix our new parameter, the gamma, based on the data. This is the Holt-Winters method. And interestingly, there's actually two variants of this. We actually have the multiplicative seasonality, where we add this, and we have the multiplicative seasonality where we multiply it to our forecasts. And again, I've got two different values here. So I've got some morph sales data here, and I've got Kohl's, the famous retailer, which isn't just as kind of crazy increase as Amazon. And you can see Kohl's had this growth as a discount store in the 90s and 2000s, but then it kind of leveled off. Walmart came along, online shopping kind of increased in, it increased in popularity. So we can actually make relatively good forecasts here in that we kind of, this is the actual revenue compared to, so the actual sales compared to our forecast sales. And you can see that our additive forecasts are actually forecasting pretty well. Our multiplicative over forecasted a bit. So again, I don't really want to think in terms of the equations, but want to understand the concepts of ideas of this, we're predicting a level, we're predicting a trend, and we're predicting the seasonality. Okay, so the final little slide, we have some hints. Before you actually look at, just look at your data. Do you see any trend or seasonality in the data? You can fit multiple models. You could fit a Holt and a Holt-Winters to see if there's enough seasonality to make the Holt, see which one has the lowest errors. If you see an obvious trend, then fitting exponential smoothing doesn't make any sense at all. Also think a little bit about your prediction task. What are you trying to do? Are we always just predicting the next day sales? If we're a movie, are we just predicting like the opening weekend sales to work out our concessions? Or do we want longer term forecasts over 5 years? Obviously, the further out you are, the less accurate your forecasts are. What sort of data are we going to have to build our model? Are we just going to have the series? For example, if we're predicting retail sales, are we just going to have retail sales information, or are we also going to have consumer sentiment information? So based on this analysis, we'd build our model as we're going to do in the kind of, as you do in the chapter and as we do in our kind of Excel videos, and we basically select the model based on error. And then once we've decided our model, then we do our actual forecasting. So that's just kind of a basic run through of how we do forecasting. And now I'll kind of move on to the specific Excel implementations of forecasting techniques.